All right, guys. I'm going to try something new today. I'm going to record Algebra 2 on Zoom. I could send the link out if anybody wants to join live if they want, but I figure I'd give this a shot since today we're going to use a lot of graphing and we'll use Desmos to help us out a lot. So let's see how this goes. I am going to screen share this link. Okay, so hopefully this will work. I don't have to watch this video and hopefully everything works out all right. So today what we're going to do is we'll look at an equation and determine the characteristics of it. So what is the center of it? We're going to try to name one of the vertices, one of the co-vertices, and then length of the major and minor axis. So we're no longer naming the equation. We are getting the information from the equation. So going backwards for what we've done the last couple of days. So what we can do here is always look at an equation and get the center from the h, which is the number subtracted from the x, and the k, which is the number subtracted from the y. So we could say this is at 0, 6. Now here's where it becomes a little bit difficult if we were trying to do this just by hand without graphing this. If I wanted to name one of the vertices, I would have to know which one's the major vertice, which in this case it would be the y, because that's the larger number. And I'd have to figure out its distance by taking the square root of that, which would be 11, and then adding or subtracting that to the y part of the center. So it would be, the x would be left alone, the y part of the center, I'd add 11, or I would subtract 11. It actually doesn't matter since it just says name one of them. And we'd get like 17 or -5. Now, I think this is kind of difficult to do in head, and this is actually a really easy answer, and it's still kind of difficult. So what I'm going to recommend doing is typing this onto Desmos. This will really help us out. So let's hope. I don't know if I can do that. I'm going to go to Desmos, and I'm going to type in the equation. So I think the equation was x squared divided by, was it? Man, gotta be careful where I click. 64 plus, oh no, y minus 6 squared divided by 121 equals 1. Okay, so we get this really large ellipse, an oval shape. Now, I think it's a whole lot easier. We can actually click on it, and it can tell us some spots. So if we look here, once we zoom up, we can see that, yes, the center would be around 0, 6. And if we just want to double check that, I'm going to type in 0, 6 as a point. And yeah, that was my guess. And that looks like it's right there on the center. Now, the major, or the vertices, are the points that are further away. So vertices can be up and down, or they can be left and right, but in this case it's up and down because the points are further away. Now I can click on it and it actually tells me it's at 0, 17. Actually that might just be the y-intercepts, but we can see that's the max. And remember what we said, you know, if the distance is 11 from the center, well, 0 plus, well, 0, that doesn't change, but 6 plus 11 is 17. Also going the other way, be -5. Now to get the minor, or the co-vertices that are on the minor axis, we'd have to go ahead and look here. Now on the graph, we can kind of see where they're at. It looks to be about 8, 6 and -8, 6. We would get those answers from looking at the b, the x value here, and seeing that its square root would be 8, and we can add or subtract that to it. Now I think it's easier just to kind of click on these things and find those. So we can either name one of the minor vertices or the co-vertices as 8, 6 or -8, 6, since that is a choice. So let's see, what was it, 0, 17, and then 8, 6 would work. All right, length of the major axis. So this is why I think Desmos really makes it easier. We can look at the equation to figure this out, but we could just count. The major axis goes all the way across the furthest edge. So it starts down here at -5, goes all the way up to 17. that would be an answer of 22. The way we can get that mathematically is, okay, we could take the square root of that number here, the bigger number, that's the major one, which is 11, and double it. We can do that same technique over here, and we'll double check that. The square root of 64 is 8, and if we double that, that's 16. Let's just double check. Over here, this starts at negative 8, 6. It goes over here to positive 8, 6. From negative 8 to positive 8, that's a distance of 16. So if you're a math person and you like numbers and you can do that real quick in your head and take the square root and double it, do that, that's fine. If not, use this. Okay, so we'll do one more example. Tomorrow will be very similar, so I'd recommend doing the same thing. So we got, let's see, we're gonna have to type this out. X minus 3 over 49. I'm just gonna change this equation here. Yeah, I'll just start over. X minus 3 squared over 49 plus, no, come on, y, come on, keep clicking my Zoom thing, y minus 9 over 4. Wrong one. Hey, guys. Y minus 9 over 4. Still getting used to this Zoom. I probably can move that toolbar. Equals 1. So I just typed that into Desmos. I'm going to zoom in here a little bit, get a bit closer. All right, so we can't get the center from the h and the k. The h is by the x, which is 3. The k is by the y, which is 9. It's the number subtracted. So 3, 9 would be my guess. I'm just going to type that in this point here just to get a 3, 9. Yeah, that looks definitely right in the center. So I'd say the center's at 3, 9. Can I move that? I don't know. All right, name one of the vertices. So the vertices are the furthest points away from the center on the ellipse. So in this case, it would be left and right. And actually, yeah, this is nice. If you click on it, it kind of stops and pauses there. So negative 4, 9 would be a vertice. Also, 10, 9 would be a vertice. Either one works as an answer. I'm going to put 10, 9 because that's the one I remember. And then the co-vertices are the points, actually they're highlighted here, up and down in this case because they are, you know, points perpendicular to the center, but they're just not the furthest points away. So we got 3, 11 and 3, 7. And so I'm just going to type one of those in once this box goes away. 3, 11 would work. All right, length of the major axis. Well, the major axis is the bigger number. We take the square root of that and double it. So that should be 14, but we can always double check that by looking. This is at negative 4, 9. It goes to positive 10, 9. From negative 4 to positive 10, that's a distance of 14. Come on. I wish that toolbar would go away. We can do the same thing here. This one's going to be kind of interesting. What's the length of the minor axis? Well, the minor axis starts out with 4. We'll take the square root of that, which would be 2, and double it, which would be 4. But just to verify that graphically, we're at 3, 7 going up to 3, 11. From 3, 7 to 3, 11 is a distance of 4. All right, guys. So that should help you guys out with today's quiz. Hopefully you guys were able to do that. Tomorrow's quiz, we'll take a look at that. I'll preview that right here. Is the same thing, but these equations are crazy. So if we were to just take that equation and type it in, I'm just going to give you guys a little preview here. Let's see, I won't memorize this, so this is going to take me a second. You know what I'm going to try to do? No, I don't know what I'm doing. This recording. I'll pause. I don't know. No, I'm still recording. Okay, anyways, and that's not going to work. I'm going to type this in. Is there a way I can? Oh, that's how I do it. Okay. Sorry, I couldn't get that. 4y squared minus 338x. What a crazy equation. 4y squared minus 338x plus 32y equals negative 169x squared. And then plus 443. Oh, hey, look at that. Get a nice skinny, super skinny ellipse there that we can click on and get some information from. So that would be what you guys could use to get that. So look at it, type it into Desmos, get your graph that way, find the center location, and guess where it's at, and then count the major and minor axis. All right, so let's hope this worked out all well, guys. I'll see what this video looks like. But best of luck. Hopefully this works out well. If this is a good format that you guys like, let me know. Especially when we get to our next section, hyperbolas, which will be like the last section of chapter 9. I'd rather do a lot of work on Desmos. So if this is good, give me a comment on Instagram or Facebook, or email me, not Facebook, Canvas, something. Let me know. I'm going to try to record this on put this on YouTube, and then also share it on Instagram TV. I want to just keep with the platform that you guys are used to. All right, best of luck. Have a good one. Stay safe. I'm going to record this one. Stop.